Hi everyone and welcome. In today's lesson we're going to learn about the inverse of a parabola, and if you remember from our linear lessons, inverse can be written as f to the power of minus 1 x if the original function was fx. So here we go. We are given fx is equal to 2x squared. Okay, now what does this parabola look like? Now let's just think about this for a while. So we do not have an x to the power of 1 term, so there's no left or right movement. So this parabola is in the form of ax squared plus q. Now we don't see the q, there is no number value, so it's basically plus 0. So when q is a 0, the parabola turning point is at the origin, and because this is ax squared and this a is a 2, which is a positive value, well, the legs will be pointing up. So if we have to draw it, it will look something like this. Got it? Okay, excellent. Now what we want to do is we want to take this original function and we want to rewrite it to get its inverse. Now what we do first is we change the fx to y. So now we have y is equal to 2x squared, and then we have to swap the x and y symbols around. So instead of a y we have a x, and instead of an x we have the y. Got it? And now we have to rewrite this so that the y becomes the subject of our formula. So again, we are going to get rid of the coefficient. So x divided by 2 is x over 2 is equal to y squared. And to get rid of the square so that we only have a y, we're going to square root both sides. So we end up with a positive and negative square root of x over 2 is equal to y. And there we are done. So instead of y, we can simply write f to the power of minus 1x is equal to plus or minus the square root of x over 2. And this is the inverse function. Now, if I have to draw this inverse function, it is going to look like this. Okay, but technically this is not a function, because if we choose an x value here, it's going to have a y value up here and it's going to have a y value down here. And one x value can never have two y values, then it's not a function. So what's going to happen is basically that when we are going to draw the original function, they are going to put a restriction on it. You're only going to draw the original for one of these legs, so either this one or this one, and then the inverse will also only have one leg, either this one or this one. Now let's go and see how that works. Now in this example, we are going to draw fx is equal to 2x squared for this restriction, where x is less than equal to 0. Now we do not have left or right movements, and q is a 0, so it means that our turning point is at the origin, and because this a is positive, our legs will be pointing up. But to draw this very accurately, we are going to have to make sure that we choose certain x values, and we are going to make use of a table. Now this is a very accurate way of drawing any graph. So here is our table, and we are going to choose our own x values, but the x values that we have to choose must be less than equal to 0. So we're going to choose negative x values. So here is our table with many different columns, and we're going to choose this first row to be all our x's and the second row to be y. So we choose our own x. Now I'm going to choose minus 3. I'm going to start with minus 3. You could have chosen another x value too, but I'm going to work from minus 3 towards 0. So I'm going to take this minus 3, put it in x's place with substitution. So there's going to be brackets with the minus 3 inside, and then square it, and then we do this math. So then we end up with a y value of 18. My next x value is minus 2. I substitute it in x's place. I do the math. I end up with 8. Then I'm going to choose minus 1. I'll put it in x's place. We do the math and we end up with a y value of 2. And lastly, because x must be less and equal to 0, my last x value will be 0. I'm going to put it in there. And when I do the math, I see that my y value is a 0. So here I end up with all my coordinate pairs. So my first pair is minus 3 and 18. It looks like this. So let's go plot that point. So minus 3 is somewhere over here and 18 is up here, and there we go. Now I'm not drawing it according to scale. I'm just going to try my best to draw it as accurately as possible. Now my second pair is minus 2 and 8, and here it is. So minus 2 is around here and 8 is up here. And there we go. And my second last pair is minus 1 and 2, and it looks like this. Let's go plot that point right there. And our last pair is 0 and 0, and that is on the origin, and there it is. So here is all our points for this restriction, and it makes sense because on the left side of our y-axis our x values is less than 0, and because it's on the origin our x value is also equal to 0. So let's connect these points, and there we go. So there is our parabola for this restriction. Now what we're going to do next, we are going to draw its inverse. Now remember, an inverse is the reflection in the line y equals x, which I draw right there. So basically our inverse is the mirror image of this leg of our original parabola. Now let's go and see what we can do. So we're gonna have our inverse, and we already worked it out earlier in the video as f to the power of minus 1x, which is our inverse, is equal to plus or minus the square root of x over 2. Now let's think about this quickly. So if the restriction for our original function is x is less than equal to 0, then it means that our restriction for our inverse function must be y is less than equal to 0. So we have to draw this inverse for y is less than equal to 0. Because remember, an inverse is just the x and y swapped around for our original function. So now we want our y values to be negative values, right? So we have to choose x values. That is quite easy so that the math is not that hard. For example, if we choose x as 18, 18 divided by 2, that gives us 9. The square root of 9 is plus or minus 3. And we do not care about the positive 3 because we want to have y values that's less than equal to 0. So we want the answer to be minus 3. Okay. So I'm going to start with the x value of 18. If we substitute it in there, well, we're going to end up with minus 3. My next easy x is a 8 because 8 divided by 2 is 4 and the square root of 4 is plus or minus 2, but we want the minus 2. Then we can choose 2. 2 divided by 2 is 1. The square root of 1 is plus or minus 1, but we want it to be minus 1. And the last one, because we want it to be equal to 0, 2, is a 0. So 0 divided by 2 is 0, and the square root of 0 is 0. And there is our pair. So we can write down these pairs, and there's our first one. And we can go plot it. So 18 is all the way to the right, minus 3 is down here, and there it is. Our next pair, 8 and minus 2, which looks like this. So 8 is somewhere around there, and minus 2 down here. There we go. And then we've got 2 and minus 1, that is right there, and 0 and 0 is right there on the origin. And here is all our dots or points for our inverse. So let's connect it, and there we go. So this is the mirror image of this leg. Now pay quick attention. Like if you didn't want to choose all these x's and you already have the original, you already have all of these points on the original. So look carefully. If you swap all these coordinates around, you have the coordinates of your inverse, because the inverse again is the x and y values swapped around in our original function. Okay, so you didn't have to choose your x if you had all of these points on your original function. Now, last thing, what is the range of fx? Now, fx is our original function, okay, which is this. Now, range means how low to how high does this function go? So let's look at this leg. How low does it go on our y-axis? Well, it touches 0. How high does it go? Now remember, this graph will continue to go up to infinity. So it's all the values from 0 all the way up. So we can say our range, which talks about how low to how high, is our y values. So it's for all the y values that's greater and equal to 0, because it starts at 0, that's the lowest point. And how high will it go? It will go up to infinity. Okay, now why do I mention this? Because if we change this y to an x, it is the domain of our inverse function. Again, the inverse is just the x and y swapped around in our original function. So if I change this y to an x, then it's not range anymore, it's domain. So our domain for our inverse function will be x is greater than equal to 0. So what does domain mean? How far to the left to how far to the right. So let's go and see if this works out. It goes as far left as 0 and all the way to the right to infinity. So it means it's all our x values from 0 all the way to infinity. So it's all the x values greater than equal to 0. Do you see? So again, there's a lot of things to pay attention to, and I hope to see you again next time. Bye.